Hello everyone, welcome to another Leetcode video. Today we're looking at alternating groups 2. This was question 3 in Biweekly Contest 134. This is a pretty cool problem. So the problem reads that there is a circle of red and blue tiles. We're given an array of integers colors and an integer k. The color of each tile I is represented by colors I. And if colors I is 0, it means the tile is red. If colors I equals 1, that means the tile is blue. So an alternating group is every k contiguous tiles in a circle with alternating colors. So you can see what that means here. These are the 3 alternating groups from this example. So here you see we have red, blue, red. Here we have blue, red, blue. And here we have red, blue, red. And we're looking at groups of size 3 because we're given k of 3. And basically what we want to do is, given those colors and given that integer k, we want to find the number of consecutive groups of size k. However, there is a little wrinkle to this question where this array technically is circular, right? So we could end up actually going around the end of the array. So say that, for example, this area was blue, right? What we could do is say this end of the array, 3, 4, 0, actually wraps around, right? So we have to find these consecutive groups, but we have to also treat this array as circular. So let me undo that. So you'll see that the 3 groups we have here for this array 0, 1, 0, 1, 0 are this starting at 0, this starting at 1, and this starting at 2. So let's take a closer look at an example and see exactly how we can solve this. So one little trick that I always like to do with these circular array problems is try representing this original array as actually an array that is double the length. And let's see what that looks like. So our original array would be 0, 1, 0, 0, 1, 0, 1. I'll just mark this as the end. So then what we would do is actually make this array double the length with the same elements, right? So what we can do is 0, 1, 0, 0, 1, 0, 1. So this would be the actual array that we're working with. And why do we do this? Well, we don't have to, but I tend to find that it's a little easier to deal with the logic of wrapping around, like by having it all in one large array, rather than trying to like do some modulo operation and kind of like figure out where we are in the array if we're at the end or the front. So I just think this is a bit easier for me personally. We don't have to do this. There is a slight space trade-off since now our space is 2n instead of n, right? So that's one thing to consider in an interview, maybe bring it up, but for this question, we're going to use this approach and just kind of understand how this is going to work. So one kind of maybe brute force obvious thing we could do is, if we have a k of 6, we can iterate through every group of 6 characters, check if they are alternating, and then if they are, we can update some variable to keep track of how many groups we found. So this would work, but it's very brute force, very inefficient. So for example, we'd go through this first 6, 0, 1, 0, 0, 1, 0, 1. We would check, are these alternating? They're not. Go to the next group, check all these, etc., etc. So this is an O of n times k operation, right? Because we would have to, for each group of k, for n, go through each group of k. So definitely not the most efficient way. There's a better way to do this. So what if we were able to tell if a group was alternating in constant time? So how do we do that? Well, we can use some pre-computation. So what we can do is have another array, right? So this array, what we're going to do is we're going to store at each point how many continuous alternating elements we have seen. And then we can use this in order to see if we have an alternating group in constant time. So what do we actually have in this array? So we're going to start with 1 in the first position. And what this means is that at this position, we've seen 1 alternating element. And just a group of 1 is alternating technically, so we're just going to have 1 for this 0. So now what we're going to do is go to the next one. We're going to see 1 is different than 0. So what we can do is say, take whatever we ended at with 0, and we're going to add 1 to that. So here we have 2. Likewise here, 0 is different than 1, we have 3. So now we have a different case, right? So now we see that 0 is the same as 0, so our alternating group stops here. So what we have to do then is, instead of adding to this previous, we're just going to put 1 here. And this represents that we're basically restarting a new group here and going from there. So now we'll go through, kind of do this quickly. This is alternating, 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 and this is not. This is alternating, and this is alternating, right? So this is what our final array would look like once we do that pre-computation. So how would this actually work? So let's just kind of eyeball here what the groups are that we know are alternating. So this one here, starting at the 0, 0, 1, 0, 1, 0, 1, this group right here is alternating. And let's look in this pre-computation array what these values actually look like. So you'll see that at the end, right, we have a 6, and here we have a 1. So what we can do is take these values, take like this group of 6, the beginning and ending values, and if this value is equal to k minus 1, then we know that this is a good group, right? And we'll see that 6 minus 1 equals 5, which is less than our 6 here, k minus 1. Similarly here, for this other group, and let me just delete these little lines here, we'll go to the next alternating group, which is right here. So we'll see here that we'll have 7 and 2. So likewise, what we can do is 7 minus 2 equals 5, which is also equal to this k minus 1. So essentially what we're going to do is we're going to do this pre-computation array, and then we're going to iterate through. So what we're going to do is at every point, we're going to go to minus k minus 1. So say we're at this index, we're going to go to k minus 1. So we're going to go 5 ahead. So 1, 2, 3, 4, 5. We're going to check if the difference between these is equal to k minus 1. And if it is, we can add that to our group. So I'll just say that one more time. For any index that we're at, we're going to go backwards by k minus 1 elements. So if we're here, we go back 1, 2, 3, 4, 5. And if this value, this ending value minus starting value, is equal to k minus 1, then we can add that, and we know that it is an alternating group. So doing this lets us just do this in O of n time, right? Because we don't have to go through each group of k for every element in the array. We're just doing the pre-computation once in O of n time, and then going through the array again. But now we can figure out if those groups are alternating in constant time. So let's look at the code and see exactly how this would work. So the first thing we're going to do is we're going to double that original colors array that we have. I'm calling this dupe colors, and this is literally just the same array copied twice. Then we're going to start this kind of pre-computation array with just the element 1 in there. And this is because by default, just one element technically is alternating, so we're going to consider just that first element to be alternating. Then what we do is we're going to iterate through every other element in our dupe colors array, and if the colors are the same, we're just going to append 1, and this kind of represents starting a new alternating group at that point. Otherwise, we're going to take whatever the previous value is, and we're going to add 1 to that because we're continuing a previous alternating group. So then what we do is we set up this groups variable, which is going to be our answer. Then we're going to do another loop. So the boundaries here are a little bit tricky. So we're starting at k minus 1. And this is because we don't want to start at 0, right? Because we know that we have to go backwards. So if we start at 0 and go backwards like 5 spaces, we'll be at -4, which doesn't really make sense. So we want to start this at an index where we can actually go backwards that number of steps that we need and still be in the array. And then we're going to end at the length of colors plus k minus 1. And what this is saying is that we would need to make sure that whatever index we're at, when we go backwards, that first element that we hit needs to still be within the bounds of our colors array. And this is kind of lets us do that. So then we're going to do this check, and we're going to say if the value at I minus the value at the spot at I minus k plus 1 is equal to k minus 1, then we can add that to our groups. Then at the end, we just return. So let's submit this and make sure that it works. And it does work. So this is kind of a tricky one. There's some pretty difficult kind of boundaries and different relationships to work out, but it's definitely a great question to really understand. So hopefully this is helpful, and thank you for watching.